Hello everyone. So today we are going to understand what is a space. So intuitively we all understand that space is that physical entity which is occupied by any matter in the world which exists. We also understand that space is the gap between two different bodies. Now this gap could be more or less. We give it a special name, we call it distance. So distance is a physical quantity which could be measured. Now, if we have two different bodies at the same distance from me, let's say I'm standing at this cross point and these two different bodies are at the same distance d from me, but what I see that they have gap also. These two bodies have some gap, right? So from here emerges two more things to be understood. We call it direction and area. Let's first take the direction. So direction is something which is pointed out. So although these two have the same distance, but they are pointed into different direction. So if we add this direction to the distance, we call it displacement. Now displacement is a vector quantity. We have dealt in depth in another section about the vectors. You can subscribe my channel and you can watch all those videos regarding the vectors. So let's come back to our current topic. Now next thing what we see is the area. So to area to exist, at least three bodies should be there. So it is the space which is formed by at least three bodies, and that should not be in a straight line, obviously, right? Now, so triangle is the first geometrical shape which appears and it gives us the area. Next, with the 4, 5, 6, many, right? In geometry, you understand we have different shapes and all possess area. Now, the next important and very interesting fact about area is, which you might not be knowing, is that area is a vector quantity, right? It's a surprising thing for many, right? So we will deal with the area, how it is a vector quantity and what are the different formulae to find out the area for triangle and for the different shapes, right? So we will have a video upon this, but right now let's move on. So if I just add another dimension to it, let's say I pick this point and bring it into the air, all these points, right? So I just give it a third dimension. So what we understand is this space have three dimensions. So like we begin with the first intuitively definition that space is something which is occupied by a matter, right? So all the matters have some physical quantity which is called as volume. So volume appears due to three dimensions of a space. So could we have another fourth dimension? No. So space is limited with only three dimensions, right? Now, having said that, so how to represent space? So space is represented by three dimensions, right? Now these dimensions are like we draw the axes for the graph, right? We call it x-axis, we call it y-axis. These are the negative x and y, and we have another. When I made it a tilted, don't understand it as some angle, but this means that it is in the space, the third dimension, right? So we have total of three axes, right? And if you go for the vectors like I have taught you in the vectors, so this is the I cap, J cap and K cap, right? Okay, having understood all this, now the point is, can this space only represented by three axes? The answer is no, right? We call it the Cartesian coordinate system, right? But other than this, we have also the cylindrical coordinate system as well as the spherical coordinate system, right? So to represent any point in a space, you do not require the Cartesian plane. We can represent it with the cylindrical as well as the spherical coordinate system. What are they? Just I give you a glimpse that for the Cartesian coordinate system, we have x, y and z to represent. For the cylindrical coordinate system, we have our radius, we have an angle, and the third dimension is same, the z axis, like the coordinate system. And for the spherical one, we have one radius and two angles to represent, right? So what you understand is, for space to represent it, we can also represent it with the angles, right? Now whatever it may be, right, whether x, y, z, r, phi, z, r, phi, theta, the point here is, to represent any point in the space, you require three dimensions. It might be a distance dimension, it might be the angle dimension, but it has to be represented by three dimensions, right? So by this we cover about the space. Now next time we will have something about time, and the last video about this sections, which started with the mass, we have something special and interesting which we covered in the fourth video, and that is mass, space and time. All three are relative, not absolute. So be in tune with us, subscribe my channel and do watch it. So thank you everyone for the participation.